Hello. So today we shall discuss about the filtration methods. So in the previous sessions we have seen the sedimentation process, coagulation, clariflocculators, how do clariflocculators work, what are the system components of clariflocculators, etc. Okay. So next, after during the process of water treatment, so far we have studied about the aeration, sedimentation aided with coagulation, then sedimentation with the newer concept of the clariflocculators, that is flocculation and coagulation happening in the same tanks. Okay. So next process of water treatment is filtrations. Once we remove the odor, then once we remove the sedimented solids in the form of sludge in the sedimentation process, so next process is to treat the water and remove the impurities by the process of filtration. Okay. So let us see what is meant by filtration, what are different types of filters. Okay. So filtration is the process which is done after the sedimentation process to remove very fine suspended particles and bacteria. So that means in sedimentation we are not sure that all the impurities are removed. Okay. So impurities are removed only with respect to their size. That means because of the sedimentation process, the heavier particles will settle on its own if their specific gravity is greater than water. So apart from that, when we add coagulants, so even more finer particles, that is colloidal particles, are removed and some amount of turbidity is removed. So next, even though if we have removed all these things, coarser and finer particles, so we may be having some fine suspended solids and also some bacteria. To remove that, we have to do the process of filtration. Okay. So for that, we will pass the water through the beds of fine granular media such as sand, gravel, etc. Okay, to do the process of filtration. Okay. Hence the process of passing the water through the beds of such granular material is known as filtration. Okay. In modern water treatment plants, filtration is often a polishing process to remove small flakes, bacteria that are not removed in screening, sedimentation and clariflocculation. So this is what I was telling. So to remove the impurities which are not removed by the previous process of water treatment is removed using the filtration process. Under certain conditions, filtration serves as primary turbidity removal method. So filtration, though removes pathogens, it cannot be completely removed. So there are two types of filtration process: pre-coat filtration and granular medium filtration. Okay. So we have the theory and mechanism of filtration. How actually water gets filtered? So that happens by these four phenomena. Okay. So first one is called as mechanical straining, second one sedimentation, biological metabolism, and due to electrolytic action. So due to all these processes, the water gets purified. That means the turbidity gets removed, the bacteria gets removed, and very fine suspended particles which are not removed by sedimentation and clariflocculation process can be removed by the process of filtration. Okay. So let us see in detail what is mechanical straining. Okay. So mechanical, here what happens is the suspended particles which are unable to pass through the spaces or voids of sand, grain gets arrested in them. Okay. So here what happens when you pass the water through the sand particles, okay, there will be some small white spaces present between the sand particles. So this will act as the strainer media. So that means the particles get trapped in the spaces between the sand grains, and hence because of this mechanical straining the filtration takes place. Okay. Here what happens, most of the suspended particles are removed from the upper layer of the sand itself. Okay. So these particles start forming on top of the bed, and the further it strains out the impurities. Okay. The removal takes place only in the upper few centimeters of the sand. Okay. And this is called as mechanical straining. That means due to the straining action, the filtration takes place. It is similar to the person who prepares the tea. Okay? So once we put all the ingredients for preparing the tea, so what we do is a process of straining. Okay? So because of that, the straining, the solids will be retained on the screen, and the clear tea, it comes out of the it comes and it gets collected in the container. So that is called as straining. So here the straining phenomena is done by the sand grains. That means the spaces between the individual sand grains, they trap the impurities. Okay, so then we have the process of sedimentation. So here only those particles which are coarser than white size are arrested. Here the finer particles gets arrested by sedimentation action between the whites. So along with the mechanical straining, so the small spaces between the sand grains, it will act as the small sedimentation pockets. So because of that, the spaces, white spaces present in the sand grains, the particles gets arrested and they can be removed out after the filtration process. Okay, so they cannot escape and they pass through the whites and remain settled among the sand particles, in between the sand particles. That means the small spaces in between the sand particles will act as the small sedimentation pockets or sedimentation areas, you can say. So this is another process involved in the filtration mechanism. Okay, we also have something called as biological metabolism. So like I have told you, it will not only remove very fine suspended particles, it will also remove some of the bacteria, algae and other organisms, pathogenic organisms. So they tend to deposit on the filter bed, and they thrive there for a period of time, and they are formed as a layer of a dirty skin. It is also called as sumuch deck, and it will be formed on the surface of the sand layer. Okay, so since sand is an inorganic material, so they tend to start to develop and they multiply and they form a dirty layer of the skin on the layer of the sand. So these organisms act on the impurities, food for them in water, and they break it down. Since it is an organic matter, so bacteria tend to break down this organic matter and they have their own metabolism and they grow on a layer of the sand. Okay, as water passes through the dirty skin, it's treated. Okay, so because of the dirty skin which may contain some of the bacteria, so as the water, impure water may also contain some organic matter, so the bacteria which are present in this dirty skin layer are sumuch deck, which gets formed on the layer of the sand. So when the water passes through this layer, then the water gets treated. That means the organic matter, it gets degraded, and when the thickness of this dirty skin increases, it creates a problem of mud balls. Okay, so it also creates a problem, but this has to be taken care by removing the top layer of this sand and during maintenance and operation of the sand filters. But however, this is also one of the process in the theory of sedimentation. So far we have studied about the mechanical straining, sedimentation in between the sand layers, and the biological metabolism. So apart from that, we also have the electrolytic action. Okay, so here because of the principle of electrostatic exchange, sand particles and impurities carry the opposite charge and hence neutralize each other upon the attraction. So the chemical constituent of water is altered. After some time, when all sand loses charge, it has to be renewed by the recycling. So this process also takes place in the filtration mechanism. Okay, so electrolytic action, it means the due to the charged particles, that is due to the opposite positive and negative charges which are carried by the sand particles and also the impurities present in the water, so they tend to neutralize and they are removed because of the attractive forces between the positive and negatively charged ions. So that is the reason it is called as, due to the electrolytic action, the water gets treated in the process of filtration. Okay, and as the sand loses all the charge, okay, it has to be removed. That means when after a certain period of time during operation and maintenance, we have to recycle the sand by adding the new sand, or else by the process of backwashing. So this is the process of and theory of filtration. Okay, so there are different types of filters. Okay, but most probably we have been using in most of the treatment plants on large scale the slow sand filters and rapid sand filters. Okay, and we also have something called as pressure sand filters. Okay, as the name itself suggests, the rate of filtration is slow, but it acts over huge area. Okay, it is not common nowadays because it requires very large area for the treatment of water, and also the rate of filtration is quite low. So next we have rapid sand filters. Here the rate of filtration is more. It acts on small areas with greater efficiency than slow sand filters. So it came into existence in 1910. Okay, so in 1800s the slow sand filter came into existence, and after a very long period the rapid sand filters have come into existence. After that we have something called as pressure filter. As the name suggests, it works under pressure, and it may be horizontal pressure filter or vertical pressure sand filter. It is mostly used for industrial purposes, large institutions and swimming pools. Apart from that, nowadays we have a number of types of filters. So based on the influent quality of water, like reverse osmosis, nanofiltration, microfiltration, ultrafiltration, etc. So based on the pore sizes of the membranes, so they are classified, and their methodology of treatment, so they are classified into different types such as reverse osmosis, nanofiltration, microfiltration and ultrafiltrations. Here the selection of the type of membrane processes, it depends on the influent and also effluent water quality. So that means the water quality will have the impact on the membrane selection types. So in total they are called as membrane process of water treatment, but when you go in detail, so they are classified into different types based on the membrane types, membrane modules, arrangement of membranes, and the pore size of the membranes, etc. Okay, so what is the filter media and the properties? Okay, so we have the single media filter and dual media filters as well. So single media filters contain only the filter sand. So the dual media contains the sand plus anthracite coal. Okay, so this combination will will increase the performance of the filtration, and it will improve the process of the filtration. So what should be the properties of filter media? So it should be free from clay, loam, vegetable matter and organic impurities. The filter media, that is sand, whatever we are selecting, it should be uniform in nature and size. It must be resistant and hard. It must be obtained from hard rocks such as basalt and quartz. So when kept in HCl for 24 hours, it must not lose more than 5% of its weight. Okay, so because if there is more organic matter present, so after addition of this HCl, it may lose the weight. So hence check is done to see that the sand is of good quality and of equal uniform granular size, because sand is a very important media in case of the filtration process. So care should be taken that the sand should be of the good quality, free from organic impurities, and it should be hard, and it should be uniform in size, and it should not lose more than 5% of its weight when it is kept in HCl for 24 hours. Okay, so below the sand layer we have the base as gravel bed. Okay, so here the gravel bed will act as a supporting media to the upper sand layer. Okay, so here it allows the filtered water to move freely to 100 rounds, because the spaces between sand is very less, so hence the water has to flow infiltrate at a relatively faster rate. So below the sand layer we have the gravel layer. So because of the more wide spaces, the water will move freely. Okay, And also to prevent the loss of sand, I'll filter media into under drainage system. The smaller the size of granular material, the smaller the voids or pore opening will be through the which the water has to pass, and it increases the efficiency. That means the sand layer will be there on the top, and below that the granular material will be there to support, and below the granular layer we have the under drainage system to collect the water, the filtered water. Okay, so then we have the slow sand filter. So in detail we shall see what is meant by slow sand filter, so how it is, how it works, and what is the range of its water treatment. Okay, so it consists of the following parts here. So that is called as enclosure tank. So this tank is open to atmosphere. It is a watertight basin made up of masonry and or cement concrete with waterproofing material. So because as it contains water always, so it has to be done with little waterproofing material so as to avoid the corrosion and deterioration of the concrete structure. So the depth of the tank would be in the range of 2.5 to 3.5 meter. So each unit will be having a surface area of 100 to 2000 meter square depending upon the quantity of water which is to be treated, and the bed slope will be 1 in 100 towards central drain or 1 in 200. Okay, so to facilitate the easy flow of water under the influence of gravity. So the media may consist of the sand layer 90 to 100 centimeter depth, okay, which is having a uniformity coefficient of 2 to 3. Then effective size of the sand will be in the range of 0.20 to 0.30 mm. Okay, so because of the less effective size, it is very effective in removing most of the pathogens and bacteria present in the water. Okay, so below the sand layer we have the base material. The base material total depth will be in the range of 30 to 75 centimeter. So in that again the gradation is done. Okay, so because we should not, the care should be taken to see that the top sand which is present as a filter media should not be washed away by the flowing water and reach the under drainage system. So that to prevent that, we will do the process of gradation here. So out of this total depth, the 15 centimeter will be 2 to 6 mm thickness of topmost layer, and next 15 centimeter will be of 66 to 20 mm size of the base material, and next the 20 to 40 mm, similarly 40 to 65 mm. So this will be the bottommost layer and this will be the topmost layer. That means the gradation is done so as to see that the sand should not get washed away because of the process of the filtration, and both sand and gravel out to be the free from silt, organic material, dust, clay, etc., and it should not contain any organic material. And this is the base layer as well as the top layer characteristics in the slow sand filter. So next, to collect the water, filtered water uniformly, which is flowing through a gravel bed and filter bed, the under drainage system is provided. So under drainage system consists of lateral drains. It is perforated pipes which are placed at a distance of 2.5 to 3.5 meter. Okay, it also includes the adjustable telescopic tubes, vertical air pipe through layer of sand, flow meter and head loss gauges. Okay, so in order to check the rate of filtration, and because as the filtration happens over a period of time, we have to clean the sand or we have to replace the sand, so based on the head loss. So in order to measure the head loss and to check the efficiency of filter, it also consists of the vertical air pipe and also the flow meter and head loss gauge to check the rate of filtration and for the proper operation and maintenance of the filters. And this is the image wherein you can see the picture. So this is the image of the slow sand filter, wherein you can see the different parts here. This is the inlet chamber and the water enters here, and this is the head of the water, and this is the telescopic pipe, and this is the float. The head loss or filter head can be measured using the telescopic pipe here, and this is the sand layer which acts as a filter media, and below this we have the base layer as gran, and below the gravel we have the under drains. Okay, these under drains are having the perforated pipes through which the water is collected in this chamber and it is taken to the outlet for the further process of treatment. Okay, so this is the picture of the slow sand filter and the working of slow sand filter. So here, as the filtration process happens, here as you have seen in the picture, the filter water enters into the inlet chamber, so then it descends to the filter chamber, sand plus gravel. The filter water further moves through the lateral drain to the main drain. Okay, so from the main drain water enters to outlet chamber. Here the rate of filtration is in the range of 100 to 200 liters per hour per square meter of filter bed area. As this layer is referred to as sumudge deck develops, that means that is skin layer, it becomes living quarters of vast number of microorganisms which break down organic material retained from the water, converting it into water, carbon dioxide and other oxide. Most impurities including bacteria and viruses are removed from the raw water as it passes through the filter skin and the layer of filter bed which is present just below. When the microorganisms become well established, the filter will work efficiently and produce high quality effluent which is virtually free of disease causing organisms and biodegradable matter. Okay, so since it is a slow sand filter, a dirty skin layer will act as an effective filter layer above the layer of the sand, and it breaks down the organic material, and it will also remove the pathogens from the stream of the water. Here when you talk about the performance of slow sand filter, it removes the turbidity up to 50 ppm. It removes the it is less efficient in removing color. It removes up to 20 to 25% of color. So whereas it effectively removes the bacteria. So in the range of 98 to 99%, but the disinfection still has to be done after the process of the sedimentation. So cleaning of slow sand filter. So generally the cleaning period is 20 to 30 days. So filter head is essentially the difference between water levels above filter media and outlet chamber. As filter head increases, it means clogging and cleaning must be done. So I told you during the construction of the slow sand filter, so we will be having a filter head measuring device by which the head loss can be measured. If the head loss is more, then it means that the filter media is clogged and the cleaning is necessary. The period of cleaning is 1 to 3 months, and cleaning is done by scraping the top layer of the sand, thickness of 15 to 25 mm, and it is replaced with cleaned or new filter sand. Okay, so at places where shortage of filter sand is there, then it is scraped, cleaned and dried, stored for future use. So the cleaning may be manual or automatic scraping. Okay, so this is the process of cleaning of slow sand filter. So we have seen the working, construction and the cleaning of slow sand filter. So cleaning is periodically done in an interval of 20 to 30 days. If the impurities are more, so this happens particularly in the rainy season. After the rainy season or during the rainy season, the water carries much of turbidity. So in that case, the cleaning has to be done frequently in the range of 15 to 20 days. So or else in normal other days in winters and summers, as the water will not contain much of turbidity and much of other organic and inorganic impurities, the interval can be in the range of 30 days. So but nevertheless, we come to know the cleaning with the help of the filter head. By measuring the head loss to the filter media, the period of cleaning can be known and it is subjected for cleaning. Okay, so here during the cleaning of the slow sand filters, the inlet wall and V walls, V1 and V2 outlet wall, they remain closed After this, the new or clean filter sand is placed back. Then the filter bed is refilled with filter water from below until the sand is completely covered. This is done to remove air. So then the valve 1 is opened slowly and raw water enters till desired head is reached. This setup will be remained up to 12 hours. After this, valve V2 is opened. So during this, the rate of filtration runs at 1/5 of normal, and this continues for next 12 to 15 hours. So this helps in formation of the dry skin. The next 3 to 4 days, the filtration rate is operated at 1/3 of normal until dirty skin forms over sand. After this, the rate is normalized until next cleaning. So also when cleaning is done for a number of times, the defective depth of filter media and the sand is reduced. Okay, so this is the process of cleaning of slow sand filters. Okay, so it contains only two valves, that is valve V1 and V2. Okay, they remain closed, and when the water is allowed, then the rate of filtration is started slowly from the normal to 1/5 of the normal to 1/3 of the normal, and when the dirty skin layer is correctly formed over some period of days, then it is completely allowed to operate for full flow of water, and as and when it is required, the cleaning is done based on the head loss. Next we have the rapid sand filter. So rapid sand filter holds advantage over slow sand filter, as the latter requires vast area and the rate of filtration is also quite less. So rapid sand filter requires water to be administered with a pre-treatment of sedimentation and coagulation, that is mandatory in case of rapid sand filter. So whereas for slow sand filter we may not require coagulation, but in a process of treatment the coagulation and flocculation is also mandatory. In case of rapid sand filter, it occupies less area and the rate of filtration is quite high compared to the slow sand filtration. In the period of cleaning is 2 to 3 days. It has less efficiency in removing bacteria, but it is good in removing color, odor and turbidity. Hence, it complements slow sand filters, which removes bacteria more effectively than color, odor and turbidity. Hence, these two in series can serve for best removal in the form of double filtration. That means if you want to achieve very good quality of effluent, so we can have the rapid sand filter followed by slow sand filter. It will act as a double filtration method to remove the impurities and treat the water effectively. Then coming to the construction of rapid sand filter, so it also consists of enclosure rectangular tank made up of cement concrete with waterproofing with a depth of 2.5 to 3.5 meter. Then each unit surface area of 20 to 50 meters square. So it will be arranged in series. That means the beds of the filter media, the length to width ratio will be in the range of 1.25 to 1.35. Then filter media consists of sand layer of 60 to 90 centimeter depth. It is placed over gravel support. The effective size of sand is 0.36 to 0.6 mm. Then base bed rail consists of 45 to 60 centimeter depth. The top layer of 15 centimeter consists of 2 to 6 mm of the sand grains. So next 15 layer consists of 6 to 12 mm of the gravel bed, then 12 to 20 mm, then 20 to 50 mm. So gradation is done in case of the rapid sand filter also similar to the case of slow sand filter, to prevent the sand from washing out, and also it provides the base for the above sand layer. And similar to the slow sand filter, the sand and gravel should be free from silt, organic matter, dust, clay, etc. Okay, so next to that we have the under drainage system to collect the treated water. So this under drainage system consists of perforated pipes which are again connected to a main drain, through which the water is taken out of the filtration system and allowed to go for the next process of treatment, that is disinfection. So we have different types of the under drainage system, that is perforated pipe system, pipe and strainer system, so Wheeler system, Leopold system and Wagner system. Perforated pipe system and pipe and strainer system. Okay, so it consists of the central drainer manifold. The laterals are made up of cast iron, so it is perforated on the both side. The laterals support on concrete blocks. so 4 cm above the filter bottom. So they are placed at a distance of 150 mm to 300 mm from each other. So we have pipe and strainer system. Here, instead of drilling holes into pipeline, pipe strainers are fixed and pipe is made up of the bronze or the brass. Okay, so different under drainage systems can be used, and we also have washed water troughs here. So they are provided a top of filter to collect backwash water after it emerges from sand. So they are made up of cast iron or RCC across the width or length of the tank. So the bottom of trough is kept above top of expanded sand level to prevent possibility of loss of sand during backwashing, but at the same time it must not be very high that the large quantity of dirty water is left behind in the filter. The bottom of trough should be at least 5 cm above top level of the sand. The spacing of wash water troughs will be in the range of 1.5 to 2 meter. All water delivered to it must be carried with a freeboard of 6 to 8 cm. So air compressor are used. During backwashing, sand is agitated either by water jets, mechanical rakes or compressed air. So when air is used, then we have to use the air compressor. Okay, so to clean the sand, here in case of rapid sand filters, so instead of removing the top layer of the soil, we do a process called as the backwashing process. So wherein the water with high pressure is injected through the under drainage system to the bed of the gravel and the sand to remove the clogged impurities. To collect the impure water, the canals are provided at the top, which collects the wash water and in wash water troughs, and that water is taken out, and again the filter will be put into operation. So here in working of the working of rapid sand filter, it consists of 5 to 6 different valves. Like the valve V1 is called as inlet valve, so which is used to allow the water to enter into the filtration system. Then we have V2, that is filtered water storage tank valve. We have V3, wash water valve to drain the water from the inlet chamber. So we have V4, wash water storage tank valve. So we have V5, wash water valve to drain water from the main drain, and V6, the compressed air valve. So when you see the picture, you will come to know the location of the valve and its functioning. So during normal working conditions, only valve V1 and V2 is open, the rest are closed. That means, so water will be entering into the inlet chamber, and after the process of treatment, that is when the water passes through the bed of sand and gravel and reaches the under drainage system, valve V2 is open and the treated water is collected, and all other valves are kept closed. Okay, and here you can see the valve V1, V2. So this is inlet valve, this is outlet valve, this is V3, this is V4, this is V5, and this is V6. Okay, and this is the washed water storage tank. So that means, so during the process of backwashing, this valve V4 is open and water is allowed to flow through this bed of sand and gravel to clean the clogged material in the filters, and the wash water is collected by the wash water troughs. Okay, so which are made up of the masonry or concrete, so which we have discussed during the parts of this rapid sand filter. So these are the wash water troughs, and this is the inlet chamber, and this is the level of the water. So water will be standing above the layer of the sand, and it will be constantly getting filtered, and when it passes through the layer of sand and gravel, so these are the under drainage system through which the filter water is collected, and this under drainage system consists of again a central drain. So all these small lateral drains, so they will allow the water to flow into this main central drain, through which the water is taken out by opening this valve, and it is collected in a filter water storage tank, and it is sent for the next process of treatment. Okay, so whereas during the process of backwashing, the all other valves will come into picture. So here you can see while cleaning and operation of this rapid sand filter, so the inlet valve and outlet valve will be closed, that is V1 and V2 will be closed. Then the valve V4 and V6 will be opened. So what is this valve V4? So this is the wash water pipe through which the water is allowed to backwash from the below bottom layer in the under drainage system. So here the valve V4 and V6 will be opened. Okay, so V6 is the air compressor unit. So along with the forced pressurized water, we can also have pressurized air, so as to facilitate the effective cleaning of the sand layers. Okay, so when the valve V4 and V6 are open, the wash water and air is forced up through the layer of the sand. So next we will valves close V6 and open V3 to allow wash water to come out via inlet chamber to wash water drain. Okay, so we will then close the V6 valve. Okay, so that is the air compressor valve, and will open the V3 valve. So because of that, the water when is collected in the wash water troughs, and it will come out through this V3, and the wash water is collected in the wash water drain. Okay, so after this is over, the valve V3 is closed and V3 and V4 are closed. That means the backwash water valve and the wash water collection valve will be closed. Then we will open valve V1 and V5. Okay, so this V1 is open, and we will also open the valve V5. Okay, so that the wash water should be collected. Okay, so then when all the water is has reached this wash water trough, then we will immediately, after the cleaning, it may not be properly done, so we will allow this process to happen for some amount of time till all the wash water is drained out from the filter media. So then we will close valve V5 and we will open V2 to continue the operation again. So that is only V1 and V2 will be opened during the process of the normal operation of the filter. So here to know the head loss, so the difference in the water level above the filter and that in outlet chamber of conduct is high. That means that if there is a lot of head loss. Okay, so in the beginning of operation, the head difference is less as there is no clogging of filter, but after some time the filter gets clogged. Over a period of time, as and when the impurities gets clogged on the bed of the filter, the rate of filtration slows down. So this is called loss of filter head. Okay, so when the loss of filter head is more, this signals that we have to do the cleaning of the filter. Then performance of rapid sand filter. So it removes the turbidity up to 35 to 40 ppm, reduced to 1 ppm. Then it increases efficiency in color removal below 3 on a cobalt scale. It increases efficiency in removal of iron and odor. It decreases efficiency in manganese taste removal. So bacterial removal efficiency will be in the range of 80 to 90%. So compressed air may or may not be used for cleaning, and it is cheap and economical than slow sand filter. Okay, so here in case of double filtration, water is sent to rapid sand filters and then to slow sand filters. So this method is good in removal efficiency, but it is uneconomical. Rapid sand filters in this setup is called roughening filter. That means if you have the process of double filtration wherein the water has to pass through the rapid sand filter, then when it passes through the slow sand filtration, then in that case, if it is a double filtration process, then the rapid sand filters is called as roughening filter. Okay, so this is about the slow sand filter and rapid sand filters. So rapid sand filters are commonly used nowadays for large water treatment plants. So they are very common because of the advantages, and it requires less space and the rate of filtration is high. So so far we have seen the filtration theory of filtration, slow sand filters, it's working, and the rapid sand filters, it's working, and cleaning and backwashing of the both slow sand filter and rapid sand filter. And we shall see about the comparison and other things. Maybe I'll show you with a small video description to understand more about the working of the and cleaning of the slow sand and rapid sand filters. So we shall continue in the next class.